another example of chain rule. K of x equals tangent of square root of x squared plus 2x minus 1. Actually, and the question is to find the derivative. Actually, here we have very interesting situation. We have the very interior part, x squared plus 2x minus 1, which sits inside square root, and that square root sits inside tangent. So something inside something else, which in turn also sits inside something else. And that means that we actually have two chain rules, one chain rule inside another chain rule. So let's calculate the derivative. So definitely this chain rule, in fact, it's two chain rules. So two chain rules. So let's try to do it. So like in any chain rule, we need to figure out the interior and exterior. And what is the interior, what is the exterior? Like the most interior part here is x squared plus 2x minus 1. So let me write here. X squared plus 2x minus 1. And of course, the derivative of that will be just 2x plus 2. Now, what is the exterior? To properly figure out the exterior part, we need to call this u, and then we need to plug in this u into the formula. And when we do so, it only gets inside the square root. So we'll end up tangent of square root of u. And now to calculate the derivative of this, we notice that it's again, there is something inside which is square root of u, and then something on the outside which is tangent. Which means to calculate the derivative of the exterior, we again need to apply another chain rule. It's like chain rule inside another chain rule. So I'll put by chain rule again. Exactly this second chain rule, the interior part is u, the interior part is square root of u, and the exterior part is tangent. So interior part is square root of u, and exterior part is tangent. Well, I need to use some letter here, so I cannot use u again, so I will say tangent of v. And therefore, interior is square root of u, which is same as v. V is square root of u, and exterior is tangent of v. Now let's calculate the derivatives. Derivative of the interior is the derivative of the square root of u, and this is 1 over 2 square root of u. Now, derivative of the exterior is derivative of the tangent, which is secant squared, of v. And the overall derivative of the exterior function here is, by this chain rule, it equals derivative of this exterior times derivative of this interior, which means it equals secant squared v times 1 over 2 square root of v. And since v equals square root of u, so it will end up secant squared, it will end up secant squared of square root of u times 1 over 2 square root of u. That's the derivative of the exterior function. And now we take the derivative of the exterior function. To calculate the overall derivative of the function k, we need to take this derivative of the exterior function and multiply it times derivative of the interior function, which is 2x plus 2. So the overall answer will be this. K prime of x equals. So we take the derivative of the exterior function, secant squared of square root of u times 1 over 2 square root of u, and then we multiply equals in here, in this, the very interiors, which is x squared plus 2x minus 1. So it ends up being the following. It equals secant squared of square root of x squared plus 2x minus 1 times 1 over 2 square root of x squared plus 2x minus 1, and finally times this 2x plus 2, 2x plus 2. So this is the answer. So the answer becomes pretty complicated. In fact, here is maybe an easier way to obtain the same answer. So here's another way of obtaining the same answer. So we do the derivative. Once again, there are two chain rules here. There is the very exterior function tangent, the intermediate function square root, and the very interior function x squared plus 2x minus 1. So here is the way to do it. Or maybe let's call it shortcut. You do the derivative of the very exterior function tangent, and that derivative is secant squared. And we apply this derivative to the whole thing inside, which is secant squared of square root x squared plus 2x minus 1. This is how we dealt with the very exterior function. Now we need to deal with the interior function, which is just square root. So what we do is we multiply times. Now we multiply times the derivative of the square root. And we know that the derivative of square root of u is 1 over 2 square root of u. So it's a 1 over 2 square root. But we will put the interior function here. So x squared plus 2x minus 1. So this is the way how we dealt with the square root. And then we do again times. And now we deal with the very interior function, x squared plus 2x minus 1. And for that we do derivative. We do derivative of that, and it becomes 2x plus 2, so we multiply times with 2x plus 2. Of course we get the same answer as before, but it's just shortcut. So derivative of this times derivative of the square root, and then times derivative of the very interior part. So it is a chain of multiplications, and once again, this is why this formula or this rule is called chain rule, because typically the result of the chain rule is a chain of multiplications. It's supposed to be a pretty long formula.